Welcome back. In this lesson, we're going to begin a new unit of the IGCSE Computer Science syllabus, and that's Unit 4, Software. You're going to explore the different types of software that runs on computers. You're going to understand the role and function of an operating system within a computer, how application software is used, the role of interrupts, and you're going to look at how software can be used to translate program code and what software do we use to create programs themselves. In this particular lesson, though, we're going to be looking at the difference between system software and application software and provide examples of each. We're also going to delve a bit more deeper into the purpose of an operating system and why it is needed. And you should be able to show an understanding of the need for interrupts. So let's start by looking at software itself. Computers need software. Without software, their functionality is severely limited. Software is a series of instructions or commands that tell the computer what to do, and it is created using programming languages. Perhaps you already have some experience of Python. Programming languages like that are used to create software. Now, we need to understand two types of software. One is called system software, and the other one is called application software. So let's start with system software. System software provides the services that the computer requires, including the operating system and utility software, and these enable the computer to function and maintain efficiency. Now, examples for operating systems are Mac OS, Android, iOS, Windows. And for utilities that these operating systems use are disk repair, disk defragmentation software, even virus checkers and backup software can all be considered utility software. These make the operating system more efficient. However, we don't just think of operating systems when we're about to use a computer. We think of application software. Perhaps you want to play a game, perhaps you want to create a presentation. So application software provides the services that the user requires. However, application software can't run without an operating system. We'll look into all of this in a bit more detail in a moment. So what are the type of categories you need to know about application software? Well, they are word processors. They help write written documents. Google Docs and Microsoft Word are examples of those. There are spreadsheets, which are used to perform calculations. And examples of those are obviously Google Sheets and Microsoft Excel. You have databases, which allow users to store and search, and Microsoft Access is a good example. Of course, there's SQL as well, structured query language. And then there's the web browser, which allows the user to view and navigate websites. And there are lots of browsers around. Google Chrome, Safari, Edge, even Brave, and Firefox are examples of browsers. So how does all of this software fit together? Well, application software, the games perhaps you want to play, cannot run without an operating system. And the operating system cannot run without firmware. And firmware is basically BIOS or instructions that are stored on ROM and loaded when a computer starts. The firmware or the BIOS itself cannot run unless the bootstrap program, which is loaded the moment you turn the computer on, loads up or is started. So when you turn on a computer, the bootstrap loads. It then loads the firmware from the ROM. The firmware loads the operating system from the hard drive or the SSD. And then the user starts an application which can only run if the operating system is loaded up. So if the OS isn't loaded up, the application software cannot run itself. This is how everything fits together. Let's look at the major piece of software, which is called an operating system. And it is the operating system that makes it possible for all the different software and hardware to communicate. It also manages the basic functions such as input and output control, allows you to multitask, allows multi-programming, security, all of that. So when a computer turns on, your bootstrap will load the firmware into memory. The programs then run a security check and make sure all the hardware, processor, the memory, and the BIOS are all functioning correctly. And if everything is fine, then they start the operating system. And on screen, you can see an example of a lot of different types of operating systems. Some you might be familiar with and some you perhaps won't. But what all these operating systems have in common is they do similar things. You need to know the common functions of what operating systems do. And they include providing an interface for computer interaction. So a user interface is given for you to interact with the hardware. They control the inputs and outputs. They allow interrupt and error handling, and we're going to look at that in a bit more detail. They allow the management of hardware and peripherals. They allow the management and loading of software. They allow file management, allow you to copy, save, sort, and delete files. They manage the processor for multitasking, so different applications can run, giving you the impression that they're all running at the same time. They allow the management of memory, they allow access rights, user accounts, and firewalls, and they deal with security. And finally, they allow network communication, so allow you to communicate with other devices which might be connected to your computer. So let's look at each of these parts separately. The first function we're going to look at is the UI, or the user interface. Now, this provides a way for you to interact with the computer. Without it, most computers would be too difficult for the average person to use. You will need to be an expert. Now, most common user interfaces use windows, icons, menus, and pointers to help you navigate and use the computer. And this is called a WIMP, W-I-M-P interface. And these are used to create graphical user interfaces. So that means you use pictures or icons to run commands. Old user interfaces include command line interfaces and menu-based interfaces. Now you see menu-based interfaces when you use the ATM, you press a button and the menu comes up and then you make some more choices. In command line interfaces, you normally type commands and you have to type them accurately, because if you don't type it accurately, the computer won't accept it. And in those days, you had to remember all the commands, so only experts tended to use these type of interfaces. Now, modern user interfaces include natural language interfaces like voice. Nowadays, we also have gesture or touch-based interfaces. Now, gesture-based interfaces are quite popular with virtual reality simulators. Future developments include holographic and AR or augmented reality-based interfaces as well. Other operating system functions include running of software. So applications run on operating systems. So an operating system ensures that whatever application that's designed for it is able to run on it. So it allows those applications to access the various components like input devices, memory, processor that's connected to it. Of course, there's processor management, and here the operating system manages who has access to the CPU. It does that through the use of queues. So when software is opened up, the operating system finds it and loads it into the RAM. The CPU can then be instructed to execute or run the commands in that program. So the operating system manages the sharing of processor time. The operating system also manages the memory. It decides what happens if there's not enough memory. It keeps track of memory usage and decides how much should be given to each program. And sometimes it uses the hard disk drive space to make sure that non-essential programs don't use the main memory and are stored there. This allows it to prevent crashes. Normally, virtual memory is used for that particular purpose. Other functions include file management. A file system is created to organize all the files, and normally folders and directories are created to store them. This gives programs a consistent way to store and retrieve or access data. The operating system is also responsible for the naming, sorting, deleting, moving, and copying of files, and this normally happens at the request of the user. It uses lookup tables to relate file names to storage locations, so you can use quick search to find your files. Security is another aspect of an operating system, and it's responsible for the creation and application of user accounts and passwords. An operating system comes with many utility packages as well, such as firewalls, backup, compression, and so on. What else can it do? Well, it gives you the illusion of running multiple programs at once, and we call it multitasking. Processors only execute one instruction at a time, but they do it so fast that it gives us the impression that they're running multiple programs at once. The operating system allows this to happen by deciding which application should be executed next and for how long. So it uses memory management and processor management to allow multitasking to happen. It also allows the managing of peripherals and drivers. Now, a computer can't run without input and output devices, and these are called peripherals. Most peripherals need a driver, which translates data between the computer and the device itself. So when you think about plugging your USB hard disk drive or a SD card or a new printer, it needs a driver to be able to communicate with the operating system. The OS allows the installation of the driver, and it also manages the communication between the device and the computer itself. And how is all of this possible? Well, it's possible through the use of interrupts. An interrupt is a signal which is sent from a hardware or from a software to the operating system. The interrupt signal causes the operating system to temporarily stop what it's doing and service the interrupt. Now, interrupts are also used with the CPU, and they work exactly the same way. Ultimately, the interrupt is processed by the CPU. So in the end, the CPU deals with everything. Even the operating system will eventually pass whatever it's trying to do to the CPU. Let's get back to interrupts. The interrupt handler is part of the operating system, which is responsible for dealing with interrupt signals. So you get an interrupt, and this interrupt handler will deal with all the interrupts that are coming through. So it's like an assistant for interrupt. The interrupt handler prioritizes interruptions as they are received. So it places them in a queue as necessary. So it says, this is a high priority one, it goes up in the queue. This is a low priority one, it gets to the back of the queue. Each interrupt is serviced by an interrupt service routine. An ISR is a small program that is used to deal with interrupts and is specifically written for each interrupt. For every interruption, the current task needs to be stopped and its status saved. Whatever the results were in the register or in RAM have to be stored somewhere. So when the processor finishes its current fetch execute cycle, it will check the interrupt queue. And if an interrupt is present, it checks its priority level. So it says, well, okay, is this interrupt higher than the current task I'm doing? If it's not, then it carries on with the current task. But if the priority level is higher, then it saves the status of the current process and then it calls the interrupt service routine to handle the interrupt. When it dealt with the interrupt, it either restores the original stored process back to memory or checks the queue to make sure there are no other higher priority interrupts. And if there are, it fetches those interrupts and carries on dealing with them until all of them are dealt with. Now, interrupts are used for absolutely everything on a computer system. If your printers run out of paper, an interrupt is sent to your CPU and you see a notification on your screen. You need to know common interrupts, and on screen there's quite a few listed: hardware issues, key presses, software errors, phone calls. You're browsing on your phone and suddenly you get a phone call, you get a notification. That's an interrupt. Disk drives indicating it's ready for more data, or a program seeking attention during multitasking. Not all interrupts need intervention from the user, though. Some are dealt with automatically. And interrupts allow computers to give the impression that they are multitasking. And this is achieved through regular scheduled interruptions between programs. You finished your time, I'm going to then send an interrupt that the next program should be loaded up. This time sharing is essential, as in reality, a processor can only handle one process at a time. The operating system will use interrupts to say, well, that task's 5 milliseconds are completed. Now the next one is loaded. And then when the next one is finished, it sends an interrupt. And this cycle continues on, and the computer operates in this particular way without user intervention. Okay, with that, I'm going to interrupt our thought process and we're going to stop for this lesson. Hopefully, you should be able to answer the following questions. You should be able to describe two types of system software. You should be able to explain the purpose of an operating system, describe three functions of an operating system, explain what an interrupt is, a signal which seeks the processor's attention. This is a very important part of the syllabus. How does an operating system handle interrupts? And you should be able to describe how interrupts can support multitasking through the use of time sharings. Once their time slice is finished, an interrupt is sent for the next process to be loaded up. That's all for today. This was a big lesson, so if you do have any questions, feel free to get back to me, and I'll see you in the next one.